And thank you very much for giving me a great opportunity to provide my presentation here. And yes, I'd like to explain the titled 5G evolution and the 6G. Still, the many operators mentioning that before going to 6G, we need a success monetization of the 5G. That's important. Yes, but of course, we need to study and we need to prepare for the 6G in parallel, of course. So, and also we need to consider some kind of the story of the technology evolution from the 5G to 6G. So we are studying the variety of the technologies concerning the such kind of story from the 5G to 6G. Yeah. Oops. And yeah. I showed this slide so many times, yes, in the past, actually. So in any case, cyber-physical fusion, cyber-physical system, digital twin, metaverse, yeah, those kind of the topics are clear trend for our future business. And in order to have a nice advanced cyber-physical system, cyber-physical fusion, the huge amount of data in the physical world need to be transferred to the cyberspace. And that's processed by the AI and actuated immediately to the physical space. Those kind of the circulation is very important for the future, more and more. So in order to do that, our network need to be evolved. Much higher data rate and the capacity, lower latency, and reliability, higher reliability, and so on, as a further evolution from the 5G. And the newly extended extreme coverage, yes, the end-to-end is one of the key topic now, and I know that on this Monday, you had a end-to-end session. Yes, that's very interesting. And also extreme cost reduction and energy saving, of course, very important topic. And also, not only the AI processing, new service creation by the AI, and also AI for network is one of the key topics. So AI everywhere, yes, like this. And to address on the technical radio technologies to be addressed as a 5G evolution and 6G, we are studying these kind of topics, 4 topics. And yes, left top, millimeter wave coverage improvement. I'm fan of millimeter wave, and I really want to deploy the millimeter wave more in the 5G, for the 5G, so that the millimeter wave can be used even for the 6G era, and also those kind of technologies can be used for the sub-terahertz potentially in the 6G era. And yeah, we have a variety of the technologies, meta surface lens or RIS and so on. And yes, maybe these technologies can be used not only for the millimeter wave, but also the FR3 spectrum band also, yes, as you know, yes. And also sub-terahertz, of course. This is a very interesting topic. Maybe as day one of the 6G, it is very difficult to deploy the sub-terahertz, as you know. But maybe a mid-2030s or future of this 6G era, of course, we should prepare to deploy the sub-terahertz to cope with a huge demand of the capacity, data traffic. And also coverage extension, end-to-end, yes, very interesting and important now. And especially end-to-end interworking with TN. That is a very key topic. And also, we are very aggressive for the hubs also. Yes, and hubs potentially can provide very high performance compared with other end-to-end solutions like Leo or Zio, thanks to the very short distance. Yeah. And also industry use cases. Of course, continuously these aspects are very important for the success in the 5G business and also for the 6G. Especially for the millimeter wave coverage improvement, we have a variety of the technologies and on-glass antenna technologies, on-glass antenna or pinching antenna or using the dielectric waveguide, and also radio XO, radio fiber, radio over fiber technologies, and the OM MIMO technologies. very interesting topic, and we are addressing together with our parent company, NTT. And also radio repeater technologies, millimeter repeater system, passive and active reflector like RIS and the meta-surface lens. Yes, we are addressing these kind of the technologies to deploy in the current 5G market and potentially for the 6G era market. And meta-surface lens, yes, we conducted trials and using this kind of the meta-surface lens film on the normal glass. And potentially we conducted some simple trials and potentially more than 24 dB gain we have. And the actual deployment image is like this. And the meta-surface lens film, that's just a film. And that can be attached on the normal window of the building. And this is mainly used for the O2I scenarios. And radio from the outside can be focused on inside the room and by the meta-surface lens. And if we put the repeater at the focal point of the meta-surface lens and retransmit inside in the room, we can improve the indoor coverage drastically. Yes, and this is one of the our trial results. And the heat map shows from the top, no lens and no repeater. Yes. In this case, the 28 millimeter wave antenna is set outside the room, and radio signal from the base station antenna to the room, yes, the radio signals propagated inside the room like almost line, yes, no spread inside the room. But the center of the heat map, yes, if we put the repeater, some improvement in the coverage inside the room, but not enough. But the bottom, yes, with the lens and the repeater, we extremely expand the coverage and improve the coverage inside the room. Yes, thanks to the lens gain and also repeater gain. And yes, actually we have approximately 10 dB gain. Yes, as you can see in the graph. And also RIS. I know that many companies or academias are researching the RIS, and we also conducted some trials, RIS, and yes, we had this kind of results. Upper part it shows the result RIS, and base station is from the left, and 28 gigahertz millimeter wave is transferred on the corridor, and only the loss area, line of sight area is covered by the base station radio, but non-line of sight area, no coverage. But if we can use a lace, extremely we can extend the coverage thanks to the RIS gain. Yes. So potentially RIS is can improve the indoor coverage like this. But on the other hand, of course, we need to consider how to use this and what kind of use cases we have. Yes. So we need to study more about the actual use cases, together with some companies, academias who has an interest in the RIS. Okay, from here, I'd like to explain one of our activities on the digital twin for the area performance evaluation, so-called 6D simulator using the point cloud data. And yes, from the several years ago, yes, we developed this kind of 6D simulator. And this 6D simulator can simulate the potential performance, potential gain of the several kinds of the technologies for 6D. And before conducting the trials, this simulator approach is good to know the potential gain of the variety of the technologies of the 6D and also potential performance of the, for example, FR3 or sub-terahertz. And we developed this simulator for the several kinds of the environment, like a shopping mall, factory, and outdoor. And yes, that was very useful to know the potential gain of the 6D. But as you know, that these are some kind of the virtual environment, not the real environment. But on the other hand, our customers or partner want to know the performance of their facilities, like a factory or their real shopping mall. And of course, we can do the simulation if we can input the real environment structure by the CAD approach or something, but that's very complicated. So we use the point cloud data now. And the measurement equipment of the point cloud data is available so much now. And easily we can get the point cloud data to get the data of the structure of the inside in the building like here, or a factory, or a shopping mall. But point cloud data is just a point. And in order to do our simulation, we need a phase. So we need to change the point cloud data to the polygon data. And that can be changed and can be processed. And the polygon data is inputted our ray tracing simulator, 6D simulator, and we can get the simulation results. And this is one of the examples to show the real factory environment. And we are collaborating with Omron. And this is Omron factory, real Omron factory. And we conducted the simulations based on the point cloud data. And we can set the base station very flexibly. And in this case, 2 base stations set. And also we can set the users any place flexibly to know the performance of each user, each position. So we can see this kind of the simulation result from the multiple angle and flexibly. So this is a very good tool for our customers, and there is a possibility that we can get more business with those kind of the partners. Yes, this is a very useful approach. Yeah. Okay, so next topic. Yes, coverage extension, end-to-end. Yes, DOCOMO point of view, we like to use the multiple solutions, end-to-end, zero-layer hubs, 3 kind of the solutions, and also interwork with the TN. Yes, so 4 layers. And zero-layer hubs has each specific characteristic in terms of the coverage and the performance, depending on the distance. And yes, we will deploy any of the solution for the case-by-case basis. And we are already deploying the zero services for years, for several 10 years. And recently, we upgraded our zero services. And it can provide very wide coverage and a stable coverage, yes, already. And the Leo, we started some kind of collaboration. I will explain later. And also hubs is also very interesting solution. The distance is just 20 kilometers. Very short compared with other Leo Zero solutions. And we see that the higher performance can be achieved compared with the Leo Zero in the future. Yes. So in any case, we will intend to use all of them for case-by-case basis as a best mix manner. And regarding Zero, yes, we already providing the updated Zero services, so-called White Star 3 services using these kind of equipment. And also Leo, we agreed the strategic collaboration with Amazon Project Hyper last November. And also we started our starting business from the December last year, yes, like this. And also hubs, yes, we are collaborating with the Airbus Auto companies for years to conduct the trials and toward the actual deployment of the hubs end-to-end services in the future. Actually, we intend to, we are targeting to provide a hub service, launch our hub service from 2026, yes. And my colleagues are working so hard to conduct a trial and toward the actual deployment of the hubs services in 2026. And thanks to the short distance, we can potentially achieve the very high performance. So we can consider the variety of the use cases by the hubs. Yes, not only the disaster case, construction site solution and the remote island ships, aircraft, and yeah, and so on, many. So hopefully we can have a nice and many business model, business case with the variety of the partners. We are discussing with the variety of the partners. Many industries, many companies has a strong interest in the hubs also. So we are negotiating with those kind of the companies and organizations, and we are trying to create a business model together with them to create a win-win model for the future. Yeah. And also, it is very important to have an interwork between the end-to-end hub system and the conventional terrestrial network. Hopefully, we can provide direct access services to your normal smartphone, yes, so that you can use the any of the networks services via the hubs network and also terrestrial conventional network, terrestrial network. Hopefully, we can provide those kind of interworking services, without any control by the users, without any control, any conscious by the users. Yes, automatically switching by our network between the hubs path and also terrestrial network path. Yeah. Okay, from here, I'd like to explain our views on the AI, but already many people explained the AI, so a little bit tired of the AI topic to speak. So, but anyway, we also considering the AI-centric network. Both aspects are very important. AI for network and also network for AI. Yeah, and especially AI for the radio access network. There we have already discussed in the 3GPP so much. But even for the 6G and the future, yes, we can consider the use of the AI for many of the aspects for the radio access network. Yes, not only for the radio access control, network deployment, interface, sensing, blah, blah, blah. Many, yes. And actually, we have already started some kind of trial together with the Nokia and SKT. Thank you very much, SKT guys and Nokia guys. And yeah, and others, yes, we are conducting the many trials together with the major vendors, yeah, like this. Especially, yes, this AI interface trial. This is, yes, developed by the Nokia, and we are conducting the many trials now. And this is for the receiver side, channel estimation, equalizer, and the symbol mapping, blah, blah, blah. That is replaced by the AI processing, one box. And also, even for the transmitter side, the modulation, it's done, controlled by the AI, yes. And this is one of the trial results. Actually, as a result, we achieved around 30% gain. That is a very interesting result, and thanks to the reduction of the overhead reference signal, and also we found that the block error rate is improved so much thanks to the AI. So in total, we achieved around 30% gain. Yes, and also recently we found that the machine learning is based on some 3GPP propagation model, but if we use the other traffic, other models, propagation models, still this has a gain. Yeah, that is a very interesting result. So it means that the AI can be used for very flexibly for the variety of the environment we think. Yeah. In any case, we are now still conducting the variety of the trials using the AI. Yes, and hopefully we can provide additional results in the future. Okay, so that's my presentation. Yeah, thank you very much for your listening.